Assalamu alaikum. How are you, students? Hope you all are safe and sound in this pandemic situation. I am also fine. Dear students of Standard 9, welcome back to my physics class. Dear students, you know I have already started chapter 7 of your physics book, that is sound, and I have explained some topics from this chapter, and today I am going to explain some topics from this chapter, and those are the relation between frequency and time period, the relation between wave velocity and wavelength, and echo. So let's start the class. The relation between frequency and time period. So at first you have to know what is frequency and time period. I know you have already well known about it. So frequency. We know that the number of complete vibrations of a vibrating particle in 1 second is called its frequency. Frequency is denoted by F. Again, the time period is the time of one complete vibration. So if the time period is t, then in t second the number of vibration is 1, because time period is the time in which time one vibration is completed. So in time t, that means in t second, the number of vibration is 1. So therefore the number of vibration in 1 second, it will be 1 by t. In t second 1, so in 1 second 1 by t. But you know from here, from the definition of frequency, the number of complete vibration of a vibrating particle in 1 second is called its frequency. That means this 1 by t is equal to the frequency. So the number of vibration in 1 second is frequency. So we can write the frequency f equal to 1 by t. So this is the relation between frequency and time period. You will require this formula while doing the mathematical problem. And if it comes in the B number question that construct the relation between frequency and time period, you will answer the question writing in this way. Okay? So look, dear students, period is the time it takes for one full wavelength to pass a certain point. Frequency is wave per second. Period is seconds per wave. So frequency equal to 1 by period, that is equal to 1 by t. The relation between wave velocity and wavelength. Wave velocity. We know that number of complete vibrations in 1 second is called frequency. Again, the distance traveled by the wave during one complete oscillation is called wavelength. So if the wavelength is lambda, therefore the distance traveled in the time of one complete vibration equal to lambda, because wavelength is the distance traveled by the wave transmitting particle during one complete oscillation or one vibration, complete vibration. So the distance traveled in the time of one complete vibration equal to lambda. Dear students, this symbol is known as lambda. So the distance traveled in the time of f complete vibration equal to f lambda. Since the frequency is f, so f number of waves are produced in 1 second. So the distance traveled in 1 second by the wave equal to f lambda. But you know the distance traveled in 1 second by the wave transmitting particle equal to wave velocity. So we can write wave velocity v equal to f lambda. So you also require this formula while doing mathematical problem, and you must try to practice it by writing in your copy, then you will remember it. And this type of relation can come in your B number question that carries 2 marks. Now I will explain characteristics of sound wave. Vibration of an object produces sound wave. sound is created due to vibration. And an elastic material medium is needed for its propagation. For the propagation of sound, material medium is must, it is required. But for the propagation of light wave, no medium is required. So sound is called a mechanical wave, because mechanical wave are those waves which needed any material medium to propagate. Since the direction of propagation of wave and of particles are in the same direction, so it is longitudinal. The velocity of sound wave depends on the nature of the medium. The velocity of sound in gaseous medium is less, high in liquid and higher in solid. The intensity of sound wave is directly proportional to the square of its amplitude. Amplitude is the highest distance that wave transmitting particle travels. So the higher the amplitude, the higher is the intensity. Reflection, diffraction and superposition are possible in case of sound wave. The velocity of sound wave depends on the temperature and humidity of medium too. So look, this is the amplitude. Okay. And look, sound is a longitudinal wave and it propagates by creating compression and rarefaction or expansion, like the spring. Look, I have told you the intensity of sound is proportional to the square of the amplitude. Look at these two waves. In which wave the amplitude is more? You can see from these two figures. Here the amplitude is this one. Okay, but here the amplitude is this one. Okay, from the highest point. So obviously the amplitude is more in this case than that of this case. That's why the intensity of sound will be more in this case than that of that case, because intensity of sound is proportional to the square of the amplitude. As amplitude is more, then intensity will increases with the square of the amplitude. So in this case amplitude is more, that's why the intensity of sound wave is also more. So look, some facts about sound wave. Look, this is wavelength. That means the distance between two crests, or the distance between two trough, or the distance between two particles of the same phase is called wavelength. Or you can also tell the distance traveled by the wave transmitting particle for one complete vibration is called wavelength. So look here, same wave velocity but different frequency. Here wavelength is more, but in this case wavelength is less. So here frequency is more and here frequency is less. Okay, because if velocity is same, v equal to f lambda. So if velocity is same, then f equal to v by lambda. That means if velocity is constant, then frequency and wavelength is inversely proportional to each other. So if wavelength is more, then frequency will be less, and if wavelength is less, then frequency will be more, because frequency and wavelength are inversely proportional to each other when the velocity is constant. And sound is propagating through any material medium by creating one compression and rarefaction. Look, compression, rarefaction, compression, rarefaction. In this way sound wave travels in any material medium. Dear students, now I will explain echo, the most important thing in this chapter. And I know you have idea about echo from your class 7. In class 7, when I took your class, that time also I have explained echo. Do you remember? Echo. If anyone produces a sound standing near the bank of a river, many of us have the experience of hearing the repetition of that sound after a while. The same case happens if we produce sound standing near a hill or a building. If a sound is produced in a big empty house, the same sound is heard just after a while. These phenomena takes place due to the reflection of sound. When a sound becomes separate from its original sound and is repeated due to reflection, then this reflected sound is called echo. That means echo means reflection of sound. That means repetition of sound when where the reflected sound and original sound are separated from each other. Simply we can say that the reflection of sound is echo. So if I give you to write down the definition of echo, simply you can write the reflection of sound is called echo. That will be true. Look, here sound is created by this boy and there is an obstacle. So being obstructed from this obstacle, the sound again reaches to the source. So this phenomena is known as echo. Look, by using echo or by using reflection of sound, the depth of the well can be calculated. The minimum distance of reflector. A sound that is heard persists 0.1 second in our brain. So the minimum distance of a reflector, a sound that is heard persists 0.1 second in our brain. It is called the persistence of period of hearing. That means when we hear any sound that persists in our brain for 0.1 second. So if any new sound reaches our ear in this period, we cannot hear it. That means if any sound we hear below 0.1 second, then we cannot hear it. Therefore, for hearing an echo of any sound, the distance between the source of the sound and reflector must be such that the reflected wave cannot come back to the listener before a time of 0.1 second. If the velocity of sound in the air at 0 degrees Celsius is considered to be 332 meter per second, then in 0.1 second, sound can travel 33.2 meter. Okay. Therefore, a reflector must be placed at a minimum distance of 33.2 divided by 2 or 16.6 meter from the listener. Because here we have divided this distance by 2. Why? I think this question will arise in your mind because from the sound will created from the source, then it will be reflected back and again reaches to the listener. So in this case, the sound has to travel twice a distance. That's why we divide the total distance by 2 to get the minimum distance. So this should be the minimum distance, that means 16.6 meter will be the minimum distance of hearing echo when the velocity of sound is 332 meter per second at 0 degree Celsius temperature. And for each degree Celsius temperature, the velocity of sound increases 0.6 meter per second. Look, here I have shown you one picture. In that picture, we are seeing by using the reflection of sound, the depth of the sea can be measured. Look, from here, a sound is sent to the bottom of the sea and then it is reflected back, and that reflected sound is comes to the transmitter, and then in this way the depth of the sea can be measured. Look, by producing echo, some animals can move. Look, a bat can move by producing echo. Then a dolphin can catch its prey by using reflected sound or echo by producing echo. And then submarine. Sound waves. Sound waves are divided into three categories that cover different frequency ranges. Audible waves lie within the range of sensitivity of the human ear. Infrasonic waves, frequency below the audible range. Ultrasonic waves, frequencies above the audible range. Look, infrasonic sound that can be heard by some animal like elephant. Then 20 hertz, that is below 20 hertz. Then 20 hertz to 20,000 hertz is known as audible sound that the human being can hear, and over 20,000 hertz is known as ultrasonic sound that can be heard by bat or some other animals like dog, cat, this type of animal. So audible sound. The human ear can easily detect frequencies between 20 Hz and 20 kHz, that means 20,000 Hz. Hence, sound waves with frequency ranging from 20 Hz to 20 kHz is known as audible sound. Ultrasonic sound. The term ultrasonic applied to sound refers to anything above the frequency of audible sound and nominally includes anything over 20,000 Hz. Frequencies used for medical diagnostic ultrasound sound can extend to 10 MHz and beyond. Infrasonic sound. The term infrasonic applied to sound refers to sound waves below the frequencies of audible sound and nominally includes anything under 20 Hz. Sources of infrasonic sound in nature include volcanoes, avalanches, earthquakes, and meteorites. The eruption of the Fuji volcano in Guatemala produced infrasonic sound in excess of 120 decibels in the range below 10 Hz. Look, by using ultrasonic sound, the image of the baby unborn baby can be found out on the screen of the computer. The baby which is in the womb of pregnant mother. So the image of the baby, unborn baby, can be found out by using ultrasonic sound. Look, infrasonic sound, the sound which is below 20 Hz is known as infrasonic sound, and it cannot be heard by humans. However, animals such as whales, giraffes, and even rhinos can hear infrasonic, using it to communicate every day. Animals are very familiar with this. Look, elephant can communicate with them, then rhinoceros, then dolphin, giraffe, they can communicate with other animals by producing infrasonic sound. So dear students, I want to finish my lecture today up to this. In the next class, I must show you some mathematical problem. So till then, stay safe, stay strong. So today up to this. Goodbye everybody.